Hi everyone, today we are going to be looking at linear systems word problems. We're going to be looking at 3 mixture problems and 1 perimeter problem. Go ahead, grab a piece of paper and a pencil and let's get started. The first question, Gina wants to make 5 pounds of mixed nuts using peanuts and cashews. Her budget requires the mixture to cost her $6 per pound. If peanuts are $4 per pound and cashews are $9 per pound, how many pounds of each should she use? So the very first thing that we should do is make our let statements. Once we have our variables defined, then we can go ahead and organize our information into the chart provided. Okay, so in the chart, I'm going to fill in what we know. So for peanuts, I'm going to put the letter P under the pounds column. Cashews, I'm going to put the letter C. And for beside mixed there, I know that I want 5 pounds of the mixed nuts. So I'm going to put a 5 in there. The cost for the peanuts is $4 per pound. The cost of the cashews are $9 per pound. And we want to spend $6 per pound. Okay, so next what we're going to do is we're going to multiply the pounds by the cost to get our total. And we're going to do that in each of our columns. And this is going to help us come up with our 2 equations. So P times 4 is 4P. C times 9 is 9C. And 5 times 6 is 30. So our first equation is going to be P plus C equals 5. And our second equation is going to be 4P plus 9C equals 30. Okay, next we are going to use elimination to solve for our variable. So how many pounds of each should she use? So it doesn't matter whether we solve for P or C first. I'm going to go ahead and multiply the first equation by 4. So that means we are going to be solving for C. We're going to be eliminating the P. So go ahead and do that. Okay, so we have 4P plus 4C equals 20 for the first equation that we have rewritten. And the next equation, nothing changed, so 4P plus 9C equals 30. Okay, let's go ahead and subtract the 2 equations. Okay, when we subtract, we have negative 5C equals negative 10. Next, we're going to divide both sides by negative 5. So C is 2. So that means we need 2 pounds of cashews. Next, we are going to substitute the C equals 2 into equation number 1 and solve for P. Okay, so when we substitute in for C equals 2, P plus 2 equals 5, and then we're going to subtract 2 from each side. So that means P equals 5 minus 2 is 3. So our conclusion is that the cashews, we need 2 pounds of cashews and 3 pounds of peanuts. Let's go ahead and write our conclusion. Okay, so again, therefore, we need 2 pounds of cashews and 3 pounds of peanuts. Okay, let's look at our next example. Question 2. A coffee mix is to be made that sells for $2.50 by mixing 2 types of coffees. The cafe has 40 milliliters of coffee that costs $3. How much of the other coffee that costs $1.50 should the cafe mix with the first? Okay, so again, we are going to start by defining our variables and then putting the information into our table. Okay, let's go ahead and define our variables. Okay, so for defining the variables, we're going to let X represent the volume of $1.50 coffee. We're going to let Y represent the volume of the $3 coffee. Okay, let's fill in our chart. So we know the cafe has 40 milliliters of the coffee that costs $3. So we are going to go ahead and put that into our chart. So for the start, under volume, 40, cost is $3. We're not sure how much we need to add of the $1.50, so I'm going to put an X there. Cost is $1.50. So the final volume will be the 40 that we started with plus the X. So in the last space under the volume column, we're going to put 40 plus X, or X plus 40. And under the cost column, we need to add the $2.50. Okay, so our cost column, we have $3 that the cafe has. We're not sure how many of the $1.50 coffee we need to add, but the total with the 40 plus the unknown is going to equal $2.50 because that's how much the product is going to sell for. So now we need to come up with our total column. So to do that, we're going to multiply the volume by the cost for each of those rows, and that's going to give us the value that goes in our last column for the total. And then once we have all of this information, we can put it together to make our equations. So 40 times 3 is 120. X times $1.50 is $1.50x. And for the last space, we need to make sure we use the distributive property. So 40 plus X times 250. So 40 times 250 is 100 plus 250x. So the last column, the total column, is the column that gives us our two equations. So the first equation is y equals 150x plus 120, and the second equation is y equals 100 plus 250x. And we can combine those all together by using the substitution method. So let's go ahead and do that. Okay, so our two equations are y equals 150x plus 120. The second equation is y equals 250x plus 100. Okay, so I'm going to go ahead and sub equation 2 into equation 1 and then solve for x. Okay, so now I have 250x plus 100 equals 150x plus 120. I'm going to subtract 150 from both sides and bring that to the left. Then I'm going to subtract 100 from both sides and bring that 100 to the right. Okay, so 250x minus 150x is just 1x. So x equals 120 minus 100 is 20. So x equals 20. So the question asks how much of the other $1.50 kind of coffee would they need to add. So we've actually answered the question, so x equals 20. So we don't actually need to figure out what y equals for this particular question. Okay, so let's go ahead and make our conclusion. So therefore, she needs 20 milliliters of the $1.50 coffee. Okay, let's look at our next example. Question number 3. A chemist has 70 milliliters of a 50% methane solution. How much of an 80% solution must she add so the final solution is 60% methane? Okay, so again, we need to start by defining our variables. Then we're going to fill in our chart with the information that we know. So let's go ahead and define our variables. So for defining the variables, we're going to let x represent the volume of the 80% solution, and we're going to let y represent the volume of the 50% methane. Okay, so we're going to go ahead and fill in our chart next. So to start, the volume we start with is 70 milliliters. So I'm going to put that under the start volume. And because we have 50% of that solution, we're going to convert our percents to decimals. So 50% as a decimal is 0.5. Next, we're going to put an X under the volume that we need to add because we don't know how much we need to add. And that's of the 80% solution, so 0.8. For the final amount, so it's going to be 70 milliliters plus some unknown X, so 70 plus X. And we know we want 60% methane in total, so under the part final, 0.6. And then just like before, we're going to multiply those columns together to get our total. So 70 times 0.5 is 35. 0.8 times x is 0.8x. And we need to make sure we use the distributive property for 70 plus x times 0.6. So 70 times 0.6 is 42. And 0.6 times x is 0.6x. So again, we're going to use our last column to come up with our equations. So our first equation is y equals 0.8x plus 35. And the second equation is y equals 0.6x plus 42. We're going to go ahead and use the substitution method next and solve for x. So 0.6x plus 42 equals 0.8x plus 35. Okay, so I'm going to subtract 0.6 from both sides and bring that to the right. Then I'm going to subtract 35 from both sides and bring that to the left. 7 equals 0.2x. Next, we're going to divide both sides by 0.2. So x equals 35 milliliters. So next, we're going to substitute that 35 milliliters into one of the two equations. Okay, I'm going to go ahead and substitute 35 into equation number 1. So y equals 0.8 times 35 plus 35. Let's go ahead and simplify. Y equals 28 plus 35. So y equals 63 milliliters. Okay, let's go ahead and make our conclusions. So we need 35 milliliters of the 80% solution. We actually weren't required to figure out the y equals 63 milliliters, but we could conclude that we need 63 milliliters of the 50% methane. Okay, let's take a look at our last example. Okay, so the last question. A rectangle has a perimeter of 64 feet. The length is 4 feet more than 3 times the width. Find the dimensions of the rectangle. So same idea as before, we need to first define our variables. So I'm going to let W represent the width. And because I know the length is 3 times the width plus 4 more feet, I'm going to say that the L is equal to 3W plus 4. Okay, so I know the formula for perimeter of a rectangle is perimeter equals twice the width plus twice the length. So that's going to be my first equation. So then what I'm going to do is I'm going to substitute my dimensions into my perimeter formula. My formula is P equals 2W plus 2 times 3 times the width plus 4. Okay, let's go ahead and simplify, and then we're going to collect like terms. So I'm going to replace the P with 64. And then I have 2W plus 6W plus 8. So 64 minus 8 equals 8W. 64 minus 8 is 56. So I'm going to divide both sides by 8. So the width is equal to 7 feet. Okay, so the last thing we need to do is substitute the width equals 7 into my formula. Let's go ahead and do that. So the length is equal to 3 times 7 plus 4. So 21 plus 4 is 25. That means my width is 7 feet and my length is 25 feet. That's it for today. Thank you for your attention. Bye-bye.